Hi guys, so today we're going to go over sketching another polar graph, just because there are so many and you'll see a variation of them throughout your assignments. Now mind you, you can always use Desmos.com, that's DESMOS, to check your polar graph. But in the meantime, we're going to do one of them by hand. Now, sketching the graph of r equals 2 times cosine of 3 theta. There's a couple of steps to this that you can always take for the polar graphs. And the first one is to identify what type of graph you're dealing with. Now, in the slide before this video, I put a reference sheet of all the different types of polar graphs, and you'll match them up to the given equation and you'll be able to identify what type of shape you'll be working with. So I've copied a piece of that here for you because if you look, you have 2 cosine 3 theta. Remember, R and A are just numbers, so technically it lines up here with 2, R equals 2 cosine of 3 theta. Why this one and not that one? Because n, which is the number multiplied to theta, is 3, which is odd. So what that tells me is that I should have a rose curve with n petals, meaning with 3 petals, because n is 3. Notice if it's even, you would double that. So we're dealing with a rose curve, and I should see 3 petals. Since we're dealing with cosine, it will be symmetric with respect to the polar axis, which is also known as the x-axis. But in the polar graphs, we call them the polar axis. So just kind of making a note here that it will be the x-axis. So we should have 3 petals when we're done. Now, rather than go around the full unit circle, which some of you have been doing, which is really great, but there are a couple shortcuts I'm going to show you to find out where those 3 petals extend to. So first off, you're always going to set the cosine of 3 theta, which is what you're dealing with here, whatever part of your equation you're dealing with here. You're going to set it equal to 1 and -1, because those are the minimum and maximum values of the unit circle. So why did I just write maximum? Because technically you'll see the absolute value of it, but I'm going to use both just for this problem, just so you can see what exactly I mean by each one of this, or each one of these. So what do I mean by cosine of 3 theta equals to 1? Well, remember, 3 theta is just an angle. This is technically a trig function by itself via module 5. I know you guys didn't like that one. But I'm looking for the angles where cosine equals 1. Where does cosine equal to 1 on the unit circle? Well, that would be at 0 and at 2 pi. So that is what 3 theta equals to. 3 theta equals to 0 and it equals to 2 pi. So if you want to plug it back in, 3 theta, instead of 3 theta, plug in 0, cosine of 0 equals to 1. That is true. 3 theta equals 2 pi. Well, replace the 3 theta with 2 pi. Cosine of 2 pi equals to 1. That's also true. So what I do from here now is I get rid of theta by using my algebra. I divide 3 on both sides. So remember, when you get a trig function by itself via module 5, you're just using the unit circle, and that's what the angle will equal to. And then you can just get theta by itself afterwards if a number is being multiplied to the angle. So in this case, theta will equal to 0, and theta will equal to 2 pi over 3. Why does this matter? Okay, so this is where we want to remember cosine of 3 theta equals to 1. So if you were to replace theta with 0, cosine of 3 times 0 is 0, cosine of 0 is 1, 1 times 2 is 2. So when theta is 0, r is 2. When theta is 2 pi over 3, plug that in as well, 3 times 2 pi over 3. The 3's will cross out, leaving you with the cosine of 2 pi, which is 1. 1 times 2 is also 2. Do you have to plug these in? No. But you've just found the maximum value of r. So where theta equals to 0 and 2 pi, that's where r will equal to the amplitude, which is right here, which is 2. Same thing can be done for -1. So rather than try to solve for this, I'm looking for the angles, the trig functions by itself again. Where does cosine equal -1? Well, that's at pi. So now I'm going to get theta by itself, divide both sides by 3, and theta will equal to pi over 3. So if I replace theta with 3 pi, and I'm just showing you the proof here, you don't have to actually do this every time, but theta equals pi over 3. 3 times 3 pi over 3, 3's crossed out. Cosine of pi is -1. -1 times 2 is -2. So I've just kind of found everywhere where I'm going to see the petals extend out to its maximum value, the amplitude, which is 2. So I'm going to make 2 circles. And as we've just seen, so kind of what you've done here is just made a theta r table. But the only difference is that you don't have to go around the unit circle looking for where the petals extend to 2. This is kind of the shortcut of it. I know it doesn't really seem like one, but when theta is 0, r is 2. So here's where theta is 0. I'm going to put a point on the second circle. When theta is 2 pi over 3, r is 2. So 2 pi over 3 is about up here. I'm going to put a point on the second circle. When theta is pi over 3, r is -2. So pi over 3 is, sorry about that. 2 pi over 3 is over here. All right, so when theta is 2 pi over 3, r equals to 2, which is over here. Sorry about that. Second quadrant. And then when r is pi over, or when theta is pi over 3, r is -2. So what does the -2 mean? Well, pi over 3 is up here, correct? So if r is negative, I can't exactly plot a negative circle here. So what you do is you go directly across, and that's where r equals -2. And what happens here? Well, I'm looking for 3 petals where they extend out to, and I just have all 3 petals. 1, 2. I'm not a great artist, so don't judge. 3. And it does reflect across the x-axis, which it should, meaning one side of the x-axis looks like the other. One side of the x-axis, well, technically should look like the other. So I've learned if you color it in a little bit, you can kind of see it a little better. But that's your rose curve. All right, guys, I hope that this helps.